Hi, I'm Brittany Wickham, a science interpreter here at the Franklin Institute. And for this installment of DeSTEMber, we're going to be talking all about weather. No matter where you are in the country, you're experiencing your own version of winter. Here in the Northeast, generally it's a little bit colder, but maybe in the South, you're experiencing something totally different. All weather comes from the same three ingredients. We have energy, coming from the sun about 93 million miles away, water, which covers about 70% of the Earth, and air, which covers 100% of the Earth. So today, I want to explore a few of those ingredients and talk about those fluffy white objects in the sky, clouds. So what we have today is we're going to represent how those clouds stay up in the air. It occurs through a process called updraft. Now, as hot air rises and cool air falls, this process happens all day, every day. It's called convection, and that convection helps to cause that updraft, which keeps the clouds up in the air. But let's zoom in on just one small particle of a cloud. These clouds are made up of small water vapor particles that get evaporated, and they form around a piece of debris. So we're going to represent just one of those particles with this beach ball. Now this particle will form around a piece of debris, like I said, and it'll be able to be held up in the air by updraft. So let's try that now. So we'll start with a smaller water vapor particle. Now this will float in the air using that updraft. The updraft is going to come around the ball, keeping it nice and in the air. Now these clouds are occurring in the troposphere, about 12 miles up. So as more water evaporates, it will condense with other water vapor particles, making that one even bigger. As those water vapor particles add on, get bigger and bigger, that whole cloud is getting heavier and heavier, falling closer to the Earth. Now, once clouds get too heavy and fill with too much water vapor particles, that's when we experience precipitation. Precipitation is any form of water coming out of a cloud, either rain, snow, sleet, or hail, depending on the weather outside of the clouds. So now that we've seen a cloud up close, down to the water vapor particles, let's see what a larger cloud might look like. Now, because we're inside, we don't have the power of updraft to keep our clouds in the air. So we're going to use what we have here. Now, clouds are a really humid environment. So the first step in making a cloud indoors is to add some really hot water. So I've got some water boiling back here that we're going to add to my weather bucket here. Now, don't have to take my word for it that it is boiling. You can see the steam going up, meaning that it is very, very hot. Now, clouds, like we said, occur 12 miles in the air. But I'm not close to 12 miles tall, so we're going to have to take some liberties. We need to cool this down very, very quickly. Now, because we're doing it inside, we need to add an ingredient that isn't found in the clouds. Here at the Franklin Institute, we love to experiment with something called liquid nitrogen. Liquid nitrogen is negative 320 degrees Fahrenheit. So cold that if I touch it with my skin, it could burn me. So I'm going to need some safety gear for this experiment. So now that we have the humid area of our cloud inside the bucket already, I'm going to add the liquid nitrogen. And let's see what happens when all of those particles start condensing. So we can see our cloud right here. Now, aside from the fact that this cloud is coming from a bucket, you might notice that the cloud is moving downwards. That's because we don't have that process of updraft, keeping it up in the air. But all of this cloud is made up of smaller individual particles that have condensed together. So the more dense that clouds get, the lower they'll sit to the Earth and the darker they'll get. I associate dark clouds with thunder and lightning, a natural phenomenon that occurs a lot in weather. Now, usually those things are two separate ideas, but here, thunder is actually the resulting sound from lightning. Light travels a lot more quickly than sound does. Lightning, or light, travels around 186,000 miles per second, where sound only travels about 1,000 feet per second. So what we have here is we're going to create our own thunder and lightning experiment. I have a balloon here filled with hydrogen gas. It's extremely combustible, explosive, and flammable. And what we're going to do is blow it up. Do not try this at home. All right, here we go. 3, 2, 1. We're going to play it in slow motion to see if you can see that lightning before you hear that thunder. So the next time that you see lightning, count the number of seconds that goes by before you hear the thunder. For every 5 seconds, that lightning is about 1 mile away. So today, we experience weather through 3 main ingredients: water, air, and energy. Through those 3 ingredients, we see our clouds forming in the sky, precipitating down anything from hail, rain, snow, or sleet, all the way to thunder and lightning. So the next time you look out your window at the weather, think about all the science that goes into it. My name is Brittany, here from the Franklin Institute. Thanks for experiencing science with us.